All right, so as you saw in the blueprint, it makes, as we start coming back, and this telehandler is in line with where the second row of machinery will go back. This piece over here, what is this, David?
This is the baler to bale the clean fiber. It'll be positioned by the middle of next week. It actually goes right below the incline conveyor that we just looked at.
So this is the fiber that we'll be producing here.
This is fiber that has been decorticated.
And they tell me that this piece of equipment is so heavy that that crane cannot pick it up?
Correct.
So they're going to actually...
We've got a baler that is twice this size that still has to go in the line, which we'll have done by the end of next week.
Okay, so now coming on down, the line went behind us over here. And then this is the last step in the process, this monster piece of machinery. And we can all jump up there so you can see how high this is, so you can get an idea. David, tell us what this does.
Well, the vinyl piece of the line removes any short fiber that may still be attached to the core. What it does is when the core finally exits this piece of machinery here, it is free. The core is free of any fiber.
Okay, and lastly, what is this equipment over here?
These are the electrical control panels for the decortication line. We will be placing them in their proper location next week.
Okay, let's go outside again and expand a little bit on some of the electrical equipment and the three-phase power that was needed to run to this plant. I mean, it's a big, big undertaking putting this plant back there. And, you know, in other countries, they do all this by hand. Right?
That is correct.
And so, in industrial nations, if you want to get a large amount of product, you have to have this kind of machinery. And this is the only plant this big in all of North America.
The Northern Hemisphere. This is the largest decortication facility in the Northern Hemisphere.
Great. Okay, let's go look outside and just touch base a little bit about the electrical system that needed to be run and is already completed. Before we run outside, I just want to touch on all the stuff you told me has to be laser aligned, bolted to the floor, and made in perfect,
Correct.
From one machine to the other.
Correct. Before we can bolt it to the concrete floor, we have to level it. It has to be perfectly level. Every individual component in here has to be perfectly level. We accomplish that with a laser level to confirm that it's perfectly straight. And then each piece of machinery is shimmed to get it to the proper height. Once the proper height has been achieved, we then drill into the concrete and bolt it to the floor.
And to just give you an idea of the size and scope of this project, it takes a bit of time. It's taken a little bit longer than we thought, a couple months behind. Right? However, once it's completed, the output for this 70,000 square foot plant will be enormous, and we'll have huge profits for Hemping and all the shareholders.
Our throughput, once everything is debugged, Bruce, this thing should do easily 50,000 pounds per day.
That's awesome. A lot quicker than hand doing.
Well, we want to keep in mind, when this machine was originally brought to the United States of America, the installation time on this machine was over 12 months. I'm not going to go into the 2 years after that it took to debug it. We're not doing that here. But it took about 14 months to install this thing originally. Right now, we're about 90 days into this, and we're probably 60% complete. So I'm very proud of all of our employees for the hard work they've done to get us where we're at today. I'm very pleased.
Well, being familiar with all the equipment, running it for 4 or 5 years, before, it makes it a lot easier the second time.
That is absolutely correct.
David, we put this yellow line here, and that's for people who want to come and take a tour of the plant. I'm very, very transparent, and I believe that people want to see. That's why we do these videos, so you can see what's going on, as well as read about what's going on. So anybody's welcome at any time to come here and tour the plant and see what's going on. Now, one thing we do want to reiterate, when we start at that end, the floor here was not exactly even. So he talked about the laser aligning it and making it level.
Right.
There's 3-inch difference from that end to that end. So it was a lot of work shimming it up and getting it perfectly level.
Correct.
Right, and this, David, what does this thing do?
This is, when we're done with this, there will be a large conveyor belt that runs underneath the length of the line. And as it goes through the structural breakers, there's a good bit of core that drops out of there. And this is conveyed on downstream, which is strictly core. There's no fiber in with this.
So those long white poles that are just all white, and that's the center of the plant, which is what we make the lost circulation material out of.
Correct, that is the core of the stalk, right.
And that goes along here.
Correct, on a conveyor belt.
Okay, let's go again, out to see the electrical.
All right.
Okay, so this is just an informal walkthrough. First of all, we had to run three-phase power. And before we did that, David, you had to build this road for the power company?
That's correct. We needed an access road not only for the truck to deliver the transformer to the site, but also for the 30-ton crane to drive back here and pick the crane up, pick the transformer up off of the flatbed truck and position it where it's currently sitting.
And now this is to give you an idea of the size of the transformer, which is, and you can hear the thing humming. Right? And so we do have a huge power supply now in place for this huge plant. And it goes into the building. It'll go in right here. And we'll take a look on the other side of the wall here, the paneling that goes on the other side of this wall for the three-phase power. And let's get a closer look on the compressor. Closer look at the compressor room and the equipment we have in here. What is this big tank here?
This is an air storage tank.
And this?
This is a dryer. This is what removes the moisture from the clean air.
And this over here?
This here is the actual compressor itself. It's a 100 horse Gardner Denver air compressor.
And that runs to the pneumatics. These lines all go into the plant.
Correct.
And it goes to the pneumatic.
It's routed above the Tamafa decortication line, and there's drops coming down, air drops coming down to each piece of equipment to power the hydraulic cylinder, the pneumatic cylinders, the air cylinders.
And lastly, what is this little piece of equipment here?
This is a separate, this removes any additional water and oil that may be remaining in the air after it exits the dryer, so that it provides the plant with clean, dry air.
So again, just this little piece of the plant, you see, is a lot of equipment, a lot of connections, a lot of piping. In this case, it's air piping for the compressed air. And now let's look on the other side of, not so much this because there's nothing there yet, but on the other side of that big
Transformer.
Thank you, David. So, David, since you told me that since we moved this equipment from the old place and installed it, the electrical code changed where we have to put a disconnect here for the fire department.
Correct.
So first responders want to be able to turn off the electrical in case of any hazards in buildings. So
correct.
That's a new rule. So correct. The disconnect goes right here.
The disconnect will sit outside of the building, so the first responders have the ability to disconnect the entire power supply to the plant outside the building prior to entering the facility.
And that's a new law?
The National Electrical Code changed the law in 2011 and required that any new installation have a disconnect between the transformer outside the building and the switchgear inside the building, a fusible disconnect.
All right, so the electrical that we saw outside from that big giant transformer,
correct.
That lines come in here, and tell us what goes next.
The switchgear will sit right in here. Once the disconnect is mounted outside, power will come into the switchgear. From the switchgear, it's routed throughout the entire facility. These control panels here control all of the functions of the Tamafa decortication line. These panels house all of the DC drives, the motor starters, relays, overloads. There's every one of these controls that you see in here. The wiring runs from here to the different components on the Tamafa decortication line.
Okay, so now all these wires, it's miles and miles of wire. How many miles
correct.
of wires?
There's probably 200 miles of wire total. You've got control wire, you've got voltage wire. There's just an incredible amount of wire. The cable tray holds all of the electrical, the high voltage wire, all of the control wiring. Everything is routed through the cable tray.
And you'll also, on that same cable tray, you'll have the air compressor lines.
The air line will run right alongside of the cable tray.
And then from that, it goes into the plant over there.
Correct.
And then it drops down and connects to all the heavy equipment that we saw inside.
Correct.
Both the electrical for the motors and the
Control wiring.
All right, so all the Tamatha line is on the other side of this wall.
Correct.